CityJS. Thanks for having me. My name is Sophie. I'm going to talk to you today about how the Monzo web team went about splitting up a big React monolith into smaller pieces and the challenges that we encountered along the way. So a bit about me first. I'm a senior web engineer and I also lead the web discipline at Monzo alongside my colleague Dylan. You can find me on Twitter, or I've got a blog called Local Ghost where I write about tech things sometimes. So this is a story of how we went about splitting up parts of a monolithic web application. And some of you might be working on giant web applications every day, and some of you might never have worked on anything particularly giant. So I'm going to talk to you a bit about how we got to this point, the options that we considered, and show you what we did at the end. And I'm also going to talk a bit about the problems that we faced along the way. In case you're not familiar with us, we are a bank. We're called Monzo. I thought I'd give a quick overview. We're a bank that lives on your phone. You might have seen our bright hot coral coloured debit cards around. And a lot of people don't actually realise that we do web at Monzo because the main customer interface is our app. We're also famous for having an astonishing number of backend microservices. We've got over 1,500. I'm not sure what the exact count is at this point. But we do also have quite a few web properties as well. So first there's monzo.me, which lets you give a personalised link to send to people so they can send you money. There's also Pay Anyone, which lets you send a link to anyone that they can claim money off you. There's also our emergency banking interface in case you lose your phone and card. You can see the last 90 days of your transactions, and you can also freeze your card if you need to. And excitingly, this year we also launched our first full-featured online banking web app for our business customers, which is a monumental event for Web at Monzo, so we're all super excited about that. But our biggest web app by far is actually an internal one. It's called BizOps, which is short for Business Operations, and it's used by our brilliant customer service team, Custom Operations, or COPS as we call them, to do their jobs. So that's chatting to customers, that might be speaking to them on the phone, approving new account signups, crediting checks, you name it, it's done on BizOps. And the way that BizOps works is that you've got this concept of a task, which might be something like a conversation or a phone call, and each individual activity that someone can do on BizOps is a task, so it's like a unit of work. And the customer can have many tasks associated with them, and a COP can have several tasks on the go at once. So for example, here we've got a chat task with the customer's conversation history, and we've also got a support call task. And tasks are at the very centre of BizOps. They're one of the major extension points, so that's where the majority of the work happens. All of our web apps at Monzo are built in React, and BizOps sits on top of a GraphQL layer, which sits between our front end and our platform. And at Monzo, our code is stored in mono repos, so all of our web projects are actually in one big repository. And this makes it really easy to share libraries across projects, as well as write some really smart deployment tooling and make changes across the code base. And it also means that versions of dependencies, like for example Next.js, tend to stay in sync across projects, which is really helpful. Another thing to note is that in the case of BizOps, it's entirely client-side, and all of our COPs are using the latest Chrome and Monzo provided MacBooks or Chromebooks, so we know exactly what we're building for. Now there's nothing inherently wrong with the monolith as an architectural pattern for apps, and in fact it can also often be the most sensible option. Technically a monolith is just the term for an application that has all of its functionality in one bundle, and for many people it works fine. It's when you start operating at real scale that it starts to become a problem. And it's not just in terms of the number of users, it's actually the number of developers for us that's the biggest problem. And it becomes harder and harder to impose standards and ways of working when you've got 10 odd teams contributing to the same application. The build time slows down, deployment becomes really complicated, and changes become more complex as well, and you start treading on each other's toes. I've worked on a couple of apps that have been monoliths, and in both cases they've been growing and growing until some of the engineers step back and say, okay, we need to split this up now. So when it comes to adding to and maintaining BizOps, that's actually where the pain is. And it was always intended to be a collaborative effort. Right from the start, the vision was that parts of the app would be sufficiently abstracted so that anyone could contribute from any team. We didn't have enough web engineers to build everything ourselves, and most teams didn't usually need web work. So it means that teams wouldn't be blocked waiting for a web engineer to become available to make their changes. And the ops product team who maintain BizOps and work on the core platform are also made up of 3 squads. So you can imagine with the devs in those squads, plus all the sponsoring teams, it's become quite a large monolith with lots of people contributing. And the most frustrating part is deployment. So it ends up being like air traffic control, trying to coordinate deployment of BizOps. You need to wait for the build to run and then post on Slack to say what commit you're deploying, making sure you've tagged everyone whose PR is in the build, wait for them to test their changes, run some smoke tests. It can take ages, and especially if people are out to lunch or in meetings. And the idea was that you'd deploy as soon as you merged, but with BizOps, people never do, as they find the process quite confusing. And it's nothing like this for backend deployments. So one bash command and you're away, you're deploying. And this is the diagram of the network connections between the microservices in our backend platform. When you're a backend developer who's used to the really speedy deployment of our microservices, each of which is represented by a black dot in this diagram, you can get an idea of the granularity of these systems. It's even more frustrating. And in fact, some people actually don't realize that the deployment process is different in the front end. So they go ahead and just deploy their changes thinking they're working in isolation. I mean, you can forgive them for thinking that given how the backend is deployed. In the backend, if I'm working on, say, the service that powers chat, all of my work is isolated to that service. So I don't have to deal with anyone else's changes unless someone happens to be working on the same service as me at the same time, which is unlikely. In the front end, if I'm working on the chat task, I have to then deploy it along with everyone else's changes and who's merged their changes into master since the last deployment. And then if there's something wrong with one of the changes in the staging environment, everyone's changes have to be pulled out when we roll back. And the result of this is that changes can take a lot longer than they should to get into production. Both in the back end and on our other web apps like business banking, we deploy to production multiple times a day. So we really should be able to do the same thing in BizOps as well. And we can with the other apps. So this is our most critical web application, arguably, and it is important that we can react fast, we can fix forward, and get new functionality out as quickly and safely as we can. It's a lot safer working on code in isolation, knowing that what you're doing is highly unlikely to have any impact on anyone else working across the app. And it's much more daunting if you know that you're responsible for other people's changes as well. So giving people ownership of their deployments instills confidence in what they're deploying. So really what we were after was something like the backend system, but for the front end, being able to work on isolated bits of the application and deploy them independently so you're not treading on anyone else's toes, and you don't have to do that deployment tango every time you want to get any changes in. So any solution that we built had to be independently deployable, so you wouldn't need to deploy the host app or the core app when making changes to those parts of the app. And then the host app would have to be able to discover all of the available bundles automatically somehow so that we don't have to hard code anything. So if we imported all of the bundles into the code manually, we'd have to then deploy the core app when building the bundles anyway, which kind of defeats the point of this whole project. And we wanted to use as much existing tooling as we could, including our internal deployment tooling. It is really brilliant, and we could have spent our time and energy into automating our existing BizOps deployment system, but we didn't want to end up with completely different front-end and back-end deployment processes. And it made a lot more sense for us to integrate whatever solution we came up with into the existing back-end deployment system. So right away, our minds went to micro front-ends, and the idea is good. Different parts of an app belong to different teams, and so the different bits are actually isolated from each other. The concept of micro frontends was actually popularized by ThoughtWorks, and in fact in the 2016 edition of their ThoughtWorks Technology Radar, micro frontends was listed as something that people should adopt. And the idea was that unlike a monolithic application, micro frontends lead to smaller, more cohesive and maintainable code bases, more scalable organizations with decoupled and autonomous teams, and the ability to upgrade and update or even rewrite parts of the application in a much more incremental fashion than was previously possible. And they are pretty much microservices, but in the front end, hence the name. And this concept, quite importantly, isn't tied to any particular implementation or technology choice. But the key is being able to operate autonomously and deploy the various parts of the application independently, which is pretty much what we were after. And each piece being its own self-contained thing, whether that's an individual app or a bundle of some sort. And that way each team can build its own thing in the language or framework that it wants. And then there are a few ways of bringing it back together in the front end. Now, one of the ways that you can compose micro frontends into a larger app is to use server-side includes. That is, so rendering content through templating. So this example came, and all the following examples come from a great article by Cam Jackson on martinfowler.com. about the different ways of implementing front ends and the various advantages and disadvantages. So I do recommend giving that a read. So in this example, Nginx will replace the page variable with an HTML file that's associated with the path that the user is requesting. And then that Nginx config will specify which HTML file should be templated in. Very simple, but we have a single page React app with no need for server-side integration because we're okay with everything being client-side. So this didn't really suit our needs. Another suggestion is to have all your bundles as privately hosted NPM modules, which you can then specify as dependencies in your package JSON. And you can then import these bundles in your code as you would any other dependency. And as neat as this is, it does have the massive downside of being build time integration, which means that every time you update a module, increment a version number, you've got to rebuild the core app and install everything again. And this doesn't help us at all because we actually want to get away from having to deploy the whole app every time we make changes to our tests. Iframes. You can compose micro frontends on the client side using iframes at runtime, if anyone remembers iframes. It's a very simple solution, and for some people the isolation that iframes provide is a really good thing. But for us it wasn't suitable because we rely on a lot of shared state in the Apollo client, and it does make routing very difficult as well. If we have, say, a task and a sidebar, they wouldn't easily be able to communicate with each other. You can also import bundles at runtime using JavaScript. So the example here pulls in the bundles via script tags, and in those script files we'll define the bundles on the global window object. And each bundle has its own render function, which is called programmatically in the JavaScript code. So all of these are relatively independently deployable methods, except for maybe the build time NPM packages. And while you can deploy those on their own, it doesn't really help us with being able to only deploy that bundle when we want to release something to production. So we needed something dynamically importable as well due to the scale and the number of bundles that we're expecting to have. We don't care so much about platform or framework agnosticism because we are pretty set on React in our organisation, and keeping the tech the same actually works in our favour given how the nature of development on BizOps works with kind of sponsoring teams. And we don't need to worry about separate CI pipelines for individual things. We've got a monorepo, we've got CI set up already. And we don't need to render the bundles on the server because we're okay with having a client-side app. So the most appealing option for us was client-side JavaScript bundles, as it ticks all the boxes for what we're looking for. And so that's what we did. And thus the web chunk was conceived, a JavaScript module plus a style sheet. And this was the first name we came up with because after all, it is a chunk of a web app, right? Don't worry, we did change the name. We went with Web Nuggets for a while because we thought it was funny, and then we realised it was a pain to type out and also very stupid. So we finally settled on Weblits, which is a bit of a spiritual successor to the applet, and I think it does convey what it is rather nicely as well. So how would this work? Let's have a look first about how tasks work in BizOps. So this is our task renderer. It's a pretty basic React component which displays things and fetches some data from the backend. In our case, this is a support call task that fetches data from our backend platform, which in turn will talk to Twilio, which powers our support call system. And the entry point of the task is a JavaScript object that specifies a type for the task, a human readable label that appears in the user sidebar and in the search as well, and also the renderer component that then should be used to display the task itself. And when it comes to rendering a task, all the tasks are given the same props. So each task will have a unique ID, things like a created and updated timestamp, and information about who the task is currently assigned to, so a user ID, and then some params which will contain data specific to the task type. So what's in the params does depend on the task type. For example, a support call might have a param that contains the unique Twilio call ID that will link our call task to the call in Twilio's system. And BizOps gets these tasks from the backend, checks their types, and then chooses the appropriate renderer for that task type. So to render a task, we pull its renderer component out of the object that we got from the entry point, and then we'll feed it the task object that we got from the backend, which contains everything it needs to show all its data and do its thing. So to turn task renderers into weblets, we had a few jobs to do. When it came to preparing the code for the actual renderers, we actually didn't have to change them that much. They're already pretty self-contained, and ultimately they're just a JavaScript object with an associated React component and a style sheet. The bulk of the work was actually in building the individual bundles, deploying them somehow, and then importing them into the core BizOps application. Now, our core app is built using Webpack, which is nothing out of the ordinary for a React app. Each app has a makefile, which the builder service uses to know how to build the app. The builder service then looks for a Docker step, which runs a Docker file. Our Weblets weren't going to be running in containers, but we did want to use as much of the existing process as we could. So we put together a Docker file for Weblets, which sets various environment variables and runs yarn build as well. But the difference is, rather than setting an entry point and then running anything like you normally would with a Docker file, we're actually copying across the built Weblit bundle to a shared build directory. And the biggest difference comes after this step. So the builder runs the Docker step without knowing that it's doing anything different from deploying any other app. But then we added in a new step where it checks for the Weblit prefix in the build target. So that'll be the folder name. So it'll be like weblit.support call, for example. And if that's present, we'll run a new step in the makefile that we call post build. And this is where we upload the bundle that we just built to S3. And the URL will contain the Weblit type, so in our case, BizOps task, and the name, support call, and the hash of the current Git commit. And finally, we deploy the Weblit, using that term very loosely, in our platform by adding the new URL into our discovery service. So it's effectively a key value store, which contains our list of Weblit names and then their current URL in S3. It's a big contrast from our usual deployment process, which the rest of our apps, including our web apps, are actually deployed with Kubernetes. And with Weblets, nothing's actually running, so they're just static JavaScript and CSS files hosted in an S3 bucket. So for module discovery, BizOps will then make a call to the discovery service on load with a GraphQL query, and then it gets a list of Weblets that it goes through and imports dynamically from S3. And the Weblets are stored in the Apollo client's local cache, and we can basically cache them forever because the URL is uniquely determined by the Git commit that's in the URL. So any new Weblet that we get in will have a new Git commit, and therefore it will bust the cache, which is rather nice. So we've built our Weblets and BizOps can discover them, but now we need to actually import them into the core app. So how do we do that? Now, the example that I gave before of client-side JavaScript bundles, it does show how we can import the bundles into HTML script tags. It's straightforward, but we won't know all the Weblets up front, so there's a problem there. Because there could, and there probably will be hundreds. And we want to load them at runtime. We want to also import them at runtime. As we saw before, if we imported them at build time, so if we hard-coded this in the HTML, then we'd have to rebuild everything every time we deployed a new Weblet. So that wasn't going to work. It would be a lovely simple option to use ES6 modules, which are now supported natively in Chrome and also in a couple of other browsers as well, where one library import would point to the same URL and so be deduped across the app. And if we used it across multiple apps, it would also be deduped, which is nice. But unfortunately for us, Webpack doesn't support ES6 modules in a stable release yet. So it's an experimental feature coming in Webpack 5, I think, but that could change at any time, and it's still in beta, so we weren't really comfortable using it in a production app that was this important. And Rollup does actually build ES6 modules, but it would have basically involved us reworking the entire system to use Rollup, which isn't something we really wanted to consider at this point. Luckily for us, there's CityJS, and this is a loader which outputs ES5 compatible modules and offers dynamic import of the same, which is the really important part. It's an emulation of ES6 modules, but in a kind of traditional script-based JavaScript browser environment. And Webpack does build CityJS modules, so we get Webpack to output those, and then we can import using system.import, which is the CityJS minimal loader. And this gives us an import function out of the box that allows us to dynamically pass in modules at runtime. And what we pass in can be a file path, or more importantly, a URL, which is perfect for us because we get the Weblit URLs from the discovery service. So we iterate over the Weblets from the GraphQL query result, and then we can import them using system import. And for local development, since the Weblets are in the same repository as BizOps, the developer's already going to have them locally. So we can actually just import them normally as we would the original tasks. We've got a file that called tasks development that actually only runs in development and will resolve all the Weblit folders in the repo and then import each Weblit. And then for each imported module, we turn it into a BizOps task ready to be used and rendered. And the result? Well, it looks the same, which is the point, and there isn't really any perceptible difference from the user's point of view. But of course, no implementation is without its challenges. It's like renovating a house, so no matter how strong the foundations are, you always encounter some kind of surprises when you move walls around. And one of the challenges that we did face was bundle size. So once we got Weblit's building, we needed to address the bundle size because our experimental Weblit was weighing in at about 3 megabytes, which is pretty massive when you consider it's just a few files. And when you think about how many we were expecting to have as well, think about how much extra it would be to download. And the problem here was the number of dependencies, and each task renderer depends on React, and some of them on Apollo for GraphQL and various other helper libraries like Lodash or Moment, which can be pretty massive. And this wouldn't have been a problem if we'd been able to use ES6 modules out of the box, because they can quite easily share dependencies. But since we were using CityJS, we had to find another alternative. So we tried the Webpack DLL plugin, which lets you split bundles and map dependencies, but it didn't really play nicely with our mono repo. And quite by chance, we discovered another feature of System.js, which is the named register. And with named registers, we can list out all the dependencies we want to share between Weblets and the core apps. So these include our shared Monzo libraries like auth and components, Sentry, which we use for error logging, Apollo for GraphQL, and of course React itself. And on load, we call system.register on each of these dependencies. And what that does is allows us to pass in a name for a module, and then we can import it just as we would any other external dependency in JavaScript. So for example, React. We register our specific React dependency with the name React, and then whenever our Weblets say import React from React, System.js will resolve that to our particular dependency bundle. It's not their preferred way of resolving dependencies, so System.js actually recommend you use things like roll-up bundle splitting instead rather than named registers. But for external dependencies, it really does work a treat. And finally, then we'll run the bundles through a minifier at build time so that we can squash it down as much as we can. Another side to dependency management is that unfortunately a lot of tasks import things that they shouldn't. So some import other tasks, some import bits of the sidebar panels, which are also meant to be isolated, and you end up with this kind of dependency chain of things importing things, such as the API library importing the auth library, which imports the utils library, which imports the money formatting library. And some dependencies are just massive, which you don't notice until it's too late, like just decimal.js is surprisingly huge. So we ended up spending quite a bit of time going through and unpicking some of these dependency chains and shifting stuff into kind of shared libraries rather than importing directly from other tasks. And also replacing some larger dependencies with smaller ones where possible. It's a great analogy here from Joe Armstrong. You wanted a banana, but what you got was a gorilla holding the banana and the entire jungle. Another challenge was getting people on board. So we, both for kind of migrating things across, but also starting using Weblets in the first place. So once we got the message out that Weblets were a thing now, we wrote some documentation which really helped. So we have a self-guided web tutorial at Monzo called Web 101. And once Weblets were ready to use, I actually rewrote it so that it guides the reader through creating a brand new Weblet instead of creating an old style task. And the advantage is that anyone coming to the guide for the first time would now see Weblets as the default way to go for BizOps tasks. But we also wanted to help people actually help us migrate the tasks. So there's a lot of tasks in BizOps owned by a lot of different teams, and we just didn't have the capacity to migrate them all ourselves. But it's difficult because you're asking people to step away from whatever else they're working on. And to mitigate this, we wrote a wizard and a build script that steps you through manual tasks of migration, such as moving the directory or suggesting a name. But there's still a fair bit of manual work involved, and it's not an easy one to solve. And finally, this problem is not a technical one either, but it's a very big one in a fast-moving organization. When you're trying to do a migration or a big refactor, it seems almost inevitable that something else is going to come along and take away your focus. So in our team's case, I was actually moved off the team onto something that had a more pressing business need, which is totally legitimate, but it did leave the team down an engineer. And with something like this, it's really important to be able to articulate the importance of getting it finished and the consequences if you don't, or you'll end up with a half-finished piece of work. And so I was able to get the deployment bits finished and hook up the discovery service to the front end before I left, but it took the rest of the team a little bit longer to finish. Well, luckily we did get there, and we've now expanded the scope of Weblets to other parts of the application, not just tasks, which is really exciting. So was there a better way we could have done this? Honestly, maybe. To steal and paraphrase badly from the retrospective manifesto, we did what we could with the tools that we had at the time. And it does seem to have worked. When Webpack 5 comes out with a stable release, we might revisit the ES6 module approach. Who knows? I do want to quickly highlight why developer experience could be so important for customer experience as well. So at first glance, it doesn't seem like the Weblets doesn't seem to have any effect on customers or the cops who use the app. But our customer service is one of the most important parts of the business, and we need to make sure our customer operations staff have everything they need to do their jobs well. And for that, we need to make sure that we can make changes and fix anything that needs fixing in good time. And having these task renderers isolated in their own little bundles mean that developers can write code and ship it efficiently without having to negotiate with lots of other developers whose changes are going in as well. And the blast radius is a lot smaller if anything does go wrong. So we'd be rolling back just a tiny subset of changes rather than, say, 5 or 6 different people's code. And developer experience is a trade-off. Usually you want to prioritize customer experience, especially when it comes to things like performance or accessibility. But in this case, it is a process improvement and it's risk mitigation. As a bank, we care deeply about risk. It's just one of several initiatives at Monzo designed to make changes safer. And we want to empower and encourage people to contribute with the confidence that it's not going to result in crying or fires. And we've got, maybe 8 web developers at Monzo. The majority of contributors are backend, and we've had to put together something that suits them to make it easier for them, streamlining the process as much as possible so that it can remain productive. And at the end of the day, the convoluted process of deployment was holding them up because the system was constantly growing. And we can do it because our users are internal, so they're all on latest Chrome, they're all on the latest technology. You need to make sure if you're doing anything that involves developer experience that you know your customers and you're going to make sure that it's not going to negatively impact their experience in any way. And it's easy to dismiss developer experience as just adding stuff because it's new and exciting, but it is really important when it's about risk mitigation. So if you're building an app that needs to grow massively in a short amount of time, it is worth considering something like micro frontends from the start. So consider modularity and independent deployments. But if you're not sure, monoliths are probably fine. Our monolith was fine for 3 to 4 years. As the organisation and number of sponsoring teams was grown, we needed to change something. And Monzo's backend platform was built on microservices right from the beginning because we knew as an organisation that that was where we were heading, to large-scale operations. And it was time for the front end to head that way as well. Thank you so much for listening. You can get in touch with me via email or via Twitter if you have any questions. Thanks a lot. Enjoy the rest of the conference.
Hey, Sophie.
Hey.
That was an amazing talk. Thank you
Thank
very
you.
much for delivering it as part of it.
Thank you very much.
We're waiting for some questions to come in. Oh no, we've had one come in from Joe. Fantastic timing, Joe. So what made you pick Weblits over NPM bundling? And I love the word Weblits, by the way. When do you decide to start code splitting? And are there obvious pointers that you've got a monolith? So 3 questions in one there.
Amazing. Yeah, so with regards to Weblets over bundling, so I kind of touched on it briefly. The issue with NPM bundling is that you've still got to include the bundles at build time. So the thing that we wanted to be able to do was to deploy these bundles independently without having to rebuild and redeploy the core app, which is where the kind of time sink was. So by importing the bundles dynamically at runtime, that allows us to keep everything a bit separate. So NPM bundling does introduce the kind of same dependency of knowing what everything is at build time and importing it then. So it wasn't really an option for us.
Okay, and the second part of that was, are there any obvious pointers that you've got a monolith when you start code splitting?
That's a good question.
It is.
Yeah, I mean, I've worked on kind of a monolith before that was a quite small monolith, so you didn't really feel the pain. I think, I mean, technically any app that is just one big system is a monolith. It can be a really small one and you'll be fine forever. I think it's when you start to feel the pain of multiple teams working and deploying over each other, and builds taking a long time, and things generally slowing down, that it might be time to think, oh, should we maybe split things up? I think the teams really are the people who benefit the most from having weblets or any kind of micro front end structure, because then it's that independence that it gives you.
Okay, and in your talk you said that was linked to scale of the team. Do you have any suggestions as to what kind of size of team that micro front ends would be more suited to?
I mean, I think that's a good question. I mean, teams can vary massively in size. I mean, they should never get too big. There's that whole 2 pizza rule, although I always thought that was quite stingy, because I personally would rather have a whole pizza.
Yeah, me and you, we'd have those between us. That's it.
Definitely. But I think it doesn't. I don't think it really matters how big the team is. I think it depends how often people are, whether changes are piling up in deployments, basically. So is it stopping you from being able to deploy really, to deliver continuously, to deploy quickly, or is it is it that you're kind of having to wait for loads of different people to test the changes? It's really the number of developers rather than the kind of size of the teams, I think.
Okay, brilliant answer. So we got a quick one here. How small should weblets be, and can they be too small or large?
I mean, as small as possible, really. Can't be too small. The smaller they are, I'm assuming you're talking kind of file size or kind of bundle size.
I imagine so.
Yeah, the smaller they are, the better, because it's ultimately data that you're transmitting over the internet. So although importing weblets isn't like a blocking thing, we kind of do it in the background, but you don't want to be bringing in like several megabytes worth of bundles on every load, even if you do have the app open the whole day, and it can still kind of cause everything to grind a little bit if you've got loads of massive bundles that you're importing in. So yeah, smaller the better.
Smaller the better. And the next question is, do you have any that you can share as examples?
So I actually, in terms of functionality, okay, I'll come to that in a minute. I actually don't, I'm afraid. So that's a really interesting one, and I think we could probably kind of put one together at some point in the future, maybe on our company blog or something. That's a really good idea.
Yeah, I think it is. I'd be interested to know. So yeah, terms of functionality.
So I can't kind of give a definitive answer on that, because we've kept them quite single function. So each weblet is one task renderer. So it has a single function of like, handle support calls, or handle chat, or process this check that someone's posted in. Or in like kind of more recent work that we've been doing, it's been kind of like, a panel that shows user information, a panel that shows the cards that we've posted to this customer. So they're quite like small and like in terms of functionality. And ultimately, I think it kind of is linked to bundle size, because the less it does, the smaller the bundle size is going to be. But I think it should also be a sensible grouping of features, right? So you shouldn't just bung together like several different panels or several different kind of lists of information in one weblet if they're completely different. Because it kind of increases the likelihood that more than one team is going to have to work on it.
Okay, and sticking with Angus again, can you nest these weblets?
Nope. It's like that you're forbidden. It's just forbidden to import from another weblet, so that we can keep it super separate and make sure that they can be deployed on their own.
Yeah. Was there any other considerations to that rule apart from the deployability?
I think it just kind of, it could cause a little bit of problem with things that are imported in a different order. You can't guarantee the order that things are going to be imported in, so you could get a rather nasty runtime error if something's looking for another thing that hasn't been imported yet.
Okay, interesting. So next question, this one is anonymous. Do you have to be careful with performance when dealing with complex pages that would end up making lots of requests for components? And if so, how do you deal with it?
Totally. So all of the thing with their BizOps is it's a single page application, and it's all client side. So everything is loaded on your first load of the application, and then then we make a lot of API calls. We do have a rather large shared state in the application that holds a lot of the information that these tasks need already. So usually what they'll only end up making maybe one, maybe two API calls in the end. And we do use GraphQL for most of those. So we can kind of keep the kind of data being transmitted down to a minimum.
Yeah.
But you always have to be careful with performance, even though we're relatively lucky in that we can rely on the technology that people are using and we know exactly what they'll be using. Especially at the moment when everyone's working from home, it's especially important. We don't know what their internet's going to be like. So performance is always a consideration.
Do you think it would have been less or more of a consideration if you didn't have designated devices from work? Would you have done anything differently?
It's a good question. I think, gosh, I really don't know how to answer that one. That's a really good question. To be honest, we might have considered some of the other, like more maybe server-based options in a different way rather than just dismissing them outright, saying no, we can't do that. We might have spent a little longer looking at that, but ultimately I feel like we would have ended up in the same place. Maybe we would have waited a little longer to see if Webpack 5 was going to come out anytime soon. But otherwise, I reckon we would have come to a similar conclusion, to be honest.
Yeah. It sounds like the perfect excuse to play around with micro front ends if it's not something that had been done before within the team. So now we're talking about where the Weblets live. Do they all live in one mono repository?
They do. We love our mono repos at Monzo. So all of our front end code, including BizOps and like basically everything else, is in one repository, which is great for local development. So we don't actually import the Weblets from S3 during local development. We import them from the repo, so the local repository. And what that gives us is the ability to work on Weblets without constantly deploying them, and also make changes to the core app at the same time if we need to.
Okay. So when you think about this project in hindsight, are there any parts of it that you think might have been better as a monolith as opposed to breaking it up into micro front ends?
Honestly, having seen the effects of introducing Weblit, so the speed at which now people can work on their tasks compared to what it was before, I'd say no, like we should have done it sooner. It's been fantastic. I think we've had a few teething problems, kind of people not really, I guess, knowing how to do it, which I think is more of a kind of documentation issue than anything else. So we fixed that. And like people were visibly amazed that they could just ship it and it was gone and it was done. So it really has sped people up quite a lot. And I think that it's kind of testament to the slightly weird approach that we adopted in the end, but it's worked really well, because it means that ultimately the kind of developer experience is much the same as it was. It's just you're able to deploy it very quickly.
Yeah, it sounds like the deployment was the main reason behind doing all this kind of stuff.
Yeah, 100%.
Speaking of that deployment, you mentioned that you introduced a new deployment pipeline and you introduced some new things into the mix. Was there any internal resistance to introducing that? Did people try and convince you to stick with what's already standard within Monzo?
So it was actually an adaptation to the existing deployment.
Okay.
So no, the good thing about being a small collection of web developers in a large community of mostly backend engineers is that I sometimes feel like web is seen as slightly mystical. And so if we understand web, then we are trusted to know what we are doing. My colleague who kind of designed the deployment process is an absolute genius. So no one's ever going to question them.
Props to them then.
Yeah,
that's a high
sure.
acclaim. So I've got one last question before we have to wrap this up. And this is a personal one for me that I'm hoping to be able to steal from Monzo. Monzo is famed for its documentation and clarity of its communication. I wondered what system you use internally for managing your documentation. Is it something that's been built specifically, or is it an off-the-shelf package?
I'm interested to hear that, actually. I've never heard that before. We do have some great documentation, and I'm really passionate about documentation. So that's awesome to hear. So we have a combination of things. For most of our documentation, it lives in Notion. So that's great for kind of collaborative, living documentation. But we also have some stuff in READMEs as well in the repositories. I think we haven't really solved documentation. It's a problem everywhere I've ever worked. It's something that can be really hard to keep up to date, and it can be hard to find as well if it's not in the right place. So, for example, our component libraries will have something like Storybook, and then I think we're kind of looking at other ways to maybe keep documentation alongside code. I really want to look into something like Swagger for documenting our APIs. So there's no kind of one solution for documentation that we've really found, but the majority of stuff will be in Notion. We use it as like a kind of giant knowledge base.
Yeah. Maybe that could be another blog post for the Monzo blog.
Yes, well, actually, I do have another talk about documentation and mentoring that was my other option for this conference. So maybe you'll be able to see that another time. Fingers crossed.
And on that note, we're going to have to draw this to a close, unfortunately. We could sit here and chat for hours about the Monzo micro front ends. But Sophie, thank you very much for delivering that talk and taking the time out to record it and for this Q&A. Are you hanging around for a little bit longer?
Yeah, I'll be around.
For dinner?
Yeah.
So if anybody wants to chat with Sophie some more, find her on the tables and start a conversation.
All right. Thanks a lot.
Thank you very much, Sophie.
Thanks. Bye-bye.